Welcome back to part 9 of the Satisfactory tutorial. This is going to be the before last one. Originally I wanted to do a separate video, but I ended up doing this one instead, so there's still going to be an extra part for energy. This video is going to be focused on some bug fixing, and then we're going to be making the merger and splitter for the conveyor belts, because I think that's kind of important, and I didn't think about it originally, but we're going to be doing that in this episode, and it's rather short. So I'm going to take the chance to do a few little bug fixes here and there that I've talked about in the comments but haven't made in the videos. So the first one we're going to be going over is currently when we have an item that we want to, let's say, drop in here in our crafter, we don't actually have to put iron. So if we pick up some iron, I think we have some coal as well, I can drop the coal in here and it can transform it into iron, which is not correct. We don't want it to do that, right? So we're going to go ahead and fix that right now. Okay, so to solve this one, it's going to be very, very quick. We just want to go ahead and open our UMG for the crafting. So this one crafting item right here. We're going to go into graph right here. And we're looking for our on drop, very simply. And what we do is from our UMG item here, so right after we cast from our drag visual to be sure that we're talking about an item, we can get it right here. We want to reroute and we're going to look for our structure. And from the structure, we're simply going to compare whether the structure here in the crafting item, if its data asset type is the same. So if these two are equal, like this, you can also do a break if you prefer. If these two are equal, then that means we can just keep doing what we already have or what we already coded. Otherwise, we simply want to return false, meaning that it failed to drop. So if we select our iron ore, and we drop the coal, it works. So there's a little problem here. It's simply not getting visually replaced. So now currently if we drop it, it doesn't accept it, and it's actually reappearing here. We just can't see it, because if we go and reopen it, it's still there. So to fix that, what we need to do is a little other change, and that is this time going to be, I believe. And so this one, what we're looking for is, instead of in crafting, we need to go back to the basis, and that's in the inventory itself. And on the UMG item here, we want to do another function override. So here we don't have it yet. What we're looking for is we're looking for cancelled. And on drag cancelled is what happens when the on drop fails. And so what we want to do is we want to get our payload. We're going to cast it to UMG item. So that's the item that we're dragging. We're going to move it right here, and we're going to say set visibility to visible. So that's pretty much what we do when we were doing the swapping, where we were resetting it visible. And so now if we drag the wrong item in, it should take it into account and reset it to visible. So we want to make sure we take this one, and it reappears here. No changes, still exists. If we drag the iron, works no problem. So the next bug fix we want to do is we want to make it, because currently if we go, let's say, and play and we interact with our crafting table, we can see all these recipes, even though we don't actually want the iron ore to be craftable here, because it's not actually something that can be crafted. It doesn't have any inputs. So to solve that problem, what we need to do is we need to open our widget for that. So in our Satisfactory blueprints widgets, we're looking for our crafting, I believe. No, not that one. Crafting table. And what we'll do very simply is we're going to actually make a slight change in our items. And in this case, the one we're looking for is the iron ore, I believe. No, sorry, not the iron. It's looking for the recipe. That's my bad. In crafting, we're looking for the iron ore, the mining one, and we're going to put it to 0 here for the hammer. And so what that means is we'll tell it at least, if ever the hammer is equal to 0, that means we don't want to add the item. So now we just need to go and modify this, where we actually add our items. So we're just going to find that very quickly. Add all items right here. What we want to do is we simply want to check whether this specific recipe, if the hammer, so the amount of times you need to hit it, so get hammer, if this is superior to 0. If it is not, we don't allow it to spawn, so we simply avoid them appearing. So this should be enough to do exactly that. And on false, don't need to do anything. Let's see. If we play, we only see these three because they're the only three that actually require the hammer to work. So the rest doesn't need to be showcased. So they'll do it for that bug. So that's a fix as well. And finally, now we have one last one, which I only just noticed very recently. It's for our container. Now currently, if our container, let's say here, it'll start outputting if there are items in it. But here, if I drop my items in, it doesn't actually output, which is not correct. It can output, so it should start outputting. So we're going to go and set that up. So to do that, the first thing we need to do is a little change in our inventory, because we need to know when the inventory gets modified. So for that, we're going to make an event dispatcher, which we're going to call inventory modified. Now, we need to make sure that we can't call it here. And normally that's where you would want to call it. You would want to call it on item added. But the problem is, when the inventory gets modified, so when we call this, we're going to start outputting, meaning we're going to be modifying the inventory again, which will give us an infinite loop, meaning we can't do it this way. So we're going to have to kind of get around it, and that's what we're going to be doing now. So in our Satisfactory again, we're now going to go to the container widget, and inside of that is where we're going to actually call this. So what we're going to do is we're going to look for all items, and in all items we know when that gets modified. And so what that means, not all the time, but most of the time, if the inventory of the player changes, then that means that the item got dropped into the inventory of the storage itself. So in that case, we can simply say, well, it got modified, let's change it. So that's what we're going to do. We're going to, from storage here, call inventory modified. And so by itself, this does nothing. But inside of our storage actor, so right here, our container, in our event graph, we now have a function here that we can call from our AC inventory called inventory modified. And so we click on that to spawn our event. And on this event is where we're going to do very simply our logic to call this effect. So it's going to use a branch because we might not make a profit change, so it might not be worth it. So what we're going to check is if we can output. And if we can output, well, we start outputting. So call that here as well. And this will work. Now, originally that's what I thought as well, but currently I believe this is incorrect. I don't know why I left it as simple as this, but can output items needs to have a bit more than just this. So we're going to have to make that quick change. So the first thing we want to do is we'll just move all of this out of the way. First, we can have a branch with inventory. If inventory is empty, so on false here, because we're using is not, then we can return that we cannot output because there's nothing to output. So we don't need to do any extra research, any extra tries. It can't go. So what we want then is we want to get the outputs. And with the outputs, we can then get the keys and we can check whether they can actually spawn something. So to check whether they can spawn something. So what I'm going to do here actually is in our A buildings, I'm going to make a parent function in a second. But first we're going to do it here because it's much easier. So for each loop. And with this for each loop, we're going to check for connected builds because this is our outputs. Then we want to convert to validated because maybe there is no connected build, so this can be invalid. We're going to cast this to conveyor. And the last thing we're going to do is from our conveyor, we already have a function for this called can spawn next item. And we're actually going to be using this a few times, which is why I'm going to turn it into a function, but we're going to be using it in other children of the A buildings. So I'm going to make this into first like this. So we just want to call this because we don't want to use the whole outputs. We just want to know for an individual attach point, can it spawn instead of having to go through this process every time. So right click, collapse the function, and we'll call this function can output from attach point. And now we'll turn it to a pure cast. We'll just rename this to attach point and leave this as a return value. Now, before we go and move it to the parent, we're actually going to finish it because currently it doesn't work. And here we just need to add a return node just so that we know that if the cast failed or there is no item, we cannot keep going. So we leave it at false. And so now what we can do very simply to send it to the parent, we can right click here and say move to parent class. And so yes, that's okay, we're gonna use it once, we're gonna be recalling it anyway. So now if we compile and save, it's right here. There's no problem, still works the same because it's the same logic. There's no problem, it's the parent, it has the same stuff. And if we compile here, it's the same one, so it doesn't matter. So this will be the result. If here it can output even once, then we consider it true. And if we reach the end without being able to output, then that means false, because it means that we couldn't output. We don't actually need the parent one because the parent one still is just, well, a boolean that is true, so it's not interesting. So now if we try and add an item to it, well, actually I need an item, otherwise it's not going to work. Right here, it won't be able to do anything. Won't output because there's nothing to go. So let's just reset that to show you that it's working. And now if we go here, there's nothing to output, no problem. If we go in nothing, if we pick up an item and we drop it in, it'll start outputting, just like we want. So that's going to solve this little issue as well. Some of you may not have even noticed it, but it was there and I happened to fall upon it, so I thought I'd help and solve the problem here. And now, with all that, we can finally get into the main part of the video, and that is the merger and the splitter. So the first thing to do actually is we're going to need to import our mesh for this. So inside of our assets, I'm going to go ahead and import it. I'm going to put it in buildings, even though it doesn't really qualify for that. We're going to put it there anyway. There we go. So save. There we go. Save selected. And this is pretty much what it looks like. So now we're going to make an actor out of that. And the actor is going to be on the base class, as most of them, a buildings. So right click, create child. And we're going to actually start by making the buildings splitter. And so this kind of bothers me a bit that we have to actually, it's probably better to do it this way. So we're going to call this M and S, and we're going to do all the logic inside of this. So I just opened it by accident. But to do all of the logic in here, then we're going to make two children. And so to avoid a problem you can face with this, so now what we're going to do is we're going to add our static mesh as usual. And that's not how you write static. Static mesh. And we're going to select, well, the one we just made. So that is, I think, merger, called it. There we go. So this is what we have. And just to make things easier, we're going to go to container and we'll just copy our input and output and place them here. Now, one thing I did do instead for what I called them, I called this one south because there's going to be 4 of them at the end, and this is north. So north is used for input, or north, not north. There we go. So move these to where they should be, which is about here. It's not, doesn't matter if it's not perfect. Usually I put them at 0. There we go. The most important thing is where they are and not actually the size. That doesn't matter too much as long as you can hit them correctly. Then you don't need to worry about the rest. So then we're going to, here we're going to be splitting. So we're going to duplicate south and we'll call this one east. And so this will be here. There we go. So you could also do left, right, forwards. That might be easier. There we go. So that should be centered. Yep. And so now we can duplicate the last one, and this one will be west. In most cases, this doesn't matter. It's mainly the two that are forward, in front and behind that are important that you need to make sure you don't get wrong, because these two will always function the same way, but these two won't. So you need to make sure you know which one is which. So with this, currently we can't really do much. So visually it's there. First, we're going to start by allowing it to be spawned properly. So just let me open it up so I know what I'm doing. So one thing I kind of noticed, and I'm actually going to run a test here first. So I'm going to go into the parent, and in the parent where we do this, I'm actually going to make it so that before this, we can tell it to be not hit testable. And the reason I want to do this is because by default, when we do this, the problem when I've faced a lot, and it probably happens for you guys as well, if we go and add an item and we look right at it, sometimes it'll teleport and it can get kind of annoying. So to avoid that, I want to make it so that that's not the case anymore. So what we need to do here is right here, we're going to move this to the side. And I'm just going to go and reroute this here as well while we're at it. So it uses the same thing. And we'll do the same thing for you. There we go. Now from here, what we want is we want to get box. So we can just get the unscaled, doesn't matter. And we want to say set collision response to channel. And the channel we're looking at is visibility, not pawn visibility. And we're going to tell it to ignore. And what we're going to do then on the spawn, or not the spawn, sorry, to be more exact, what we're going to do on the build, so we can copy this all here. And in, I believe it is, so here we're going to have to override, I think. Yeah, so on place build, so that's going to be when we finished building, we're going to actually set it all to visible at the end. So we can copy this as I showed before, and we're going to put it before this just to be sure it works. And this will go on the completed. And so now we don't actually need the whole reroute, it's fine. And we want to put it back to block on visibility. And so normally what this should do is that when we build items, as long as we keep the parent place build on the children in here, then we should be able to have this happen, meaning we'll never hit the boxes as we place an item. So that does that for the small modification here. We can close 8 buildings, I believe. And now we can move on to this. Now, by default, this is going to be working for the splitter, but we're going to be making a child for it to actually work as the splitter. Okay, so the first thing to do is we're going to need to override a few functions. We're going to start by the movement. So we're looking for place build first. Now, we're going to make a minor change here because most of this is fine. We just want to have a sequence first that checks whether we're trying to place it on another build, or in our case, a container. So what we want to do here, we need to know what conveyor we're placing it on. So to do that, we need a variable for that. So this is going to be conveyor attached to. It's going to be of type conveyor. So a builds, and we're going to be setting up in a second. I just want to have it here. And for now, we don't have a function, but we're going to have a function here called split conveyor, which is going to split it up so that we can keep the same majority of the logic intact and only make a few minor changes. Next, we want the create build. Actually, no, I take that back. We don't need a create build anymore because we made the change in the parent, so that should be enough. So next is the update location. So let's get that. So open that up. And we're going to have a bit of a two-way solution here. So we're going to break. And we're going to check whether we hit a conveyor. So we're going to cast. And if not, we call this. We simply add a reference to our hit information. Not make, just hit information here. And we simply then say... So one extra thing we need to do before we just return, we need to get actors to ignore, and we need to add, oh sorry, no, in this case we want to remove item, and we want to actually move this conveyor here. There we go, so just plug this in here. And we then get to also say that this is no longer valid because we're no longer hitting a target, right? So here is where we're going to actually tell it what to do. So what we need is we need to know where we hit it. So because where we hit it is where we're allowed to then find out how close we are to the spline and where to place it on the spline. And so we're going to actually make a function for this, which is going to, from here, get spline. So any spline is like, any one of these is okay. And we want to find input key closest to world location. And we want to plug in the impact point here. And we're going to actually return this because we're going to need this as a function. So go and collapse the function, and we're going to call it get input put key by location. There we go. So this can be a pure, and this is all it needs to do. But here we're also going to need to get our spline again because we need to know what transform to use. So this is going to actually promote this here to a conveyor, to the conveyor that we made. And we're then going to say set actor transform right here. and the transform is what we need to get here. So we're going to get from here our spline again. So any one of them is okay. And we're looking for transform at input key. And that'll give us this, and make sure we swap it to world. Plug this in just to make this a bit tidier. We can just move this. Actually, because that is a variable, we can do this. And we simply need to call, sorry, let me just reroute this. There we go. And now we can just collapse this to a function, or to node, sorry. And this will be get transform by location. There we go. So the next thing we do is with these two, we add them. So add instead of remove. And because we set it before, we don't need to worry about anything else. So with this, normally, well, actually we can't do anything yet because we haven't made the input. So in our input, sorry, we want to duplicate object to object 4. In Satisfactory IMC, we're going to add it. So this is object 4 we're looking for. The input is 4. Save, and now we need to get our player to tell it, well, what item to spawn on object or input 4. So we can copy this, place it on started, and we are looking for, in our case, MS. Okay, so let's see how that works. If we now press 4, it appears. Press 2 and put a conveyor. If we move with 4, nothing happens, but the instant we get and hit our line trace on the conveyor, it will start moving along it. Now currently we can place it, but it doesn't do anything. Currently the actual conveyor is still in between, and that's not the end result we want. So one last little thing we need to do here is we need to make sure that we can tell it what conditions are. So when it's actually built. So we're going to get our is buildable. Is buildable, 2 words, sorry. And inside of this, we're going to make a few little changes. So what we need to do here is if our conveyor mesh here that we're trying to attach to is not valid, we can use the old method. We check whether there's nothing in the surrounding area of the item. On the other hand, if it is, we're going to get this. We're going to get our input key by location. Location being this time get actor location, not that one. Get actor location. And we're going to be determining how far we are in distance. So we're going to get our spline, not that one, get the actual spline itself, not the last spline, we don't care. And we want to know the distance. So we're going to say get distance along spline at input key. There we go. And so this will give us a proper distance which we're going to promote to a variable, or a local one, sorry. So this is going to be actor distance. And so with actor distance, what we're going to do is we're going to check first. We need to do one little check to check whether are we on the edge. And so if we are on the edge, we're going to return false. Now, what we do is we're going to say minus 200 and plus 200. And this is rather large, so it means you won't actually be able to place this in any location. And the reason for that is otherwise we end up with issues with the conveyor belt visually. So to keep it safe, I give a big margin. If you want to change that, that's fine, but you'll end up with a weird issue here if you do that. So then what we also need is we need to know how long the spline length is, because we want to check whether minus 200 is inferior or equal to 0. And here we want to check whether it is superior to the spline length, like this. So here we go. So if either of these are true, then we don't want any of this to happen. So we're just going to collapse this to, there we go. And this is simply going to be check on edge. Now, normally we could just remove that because it should be the same input. We just plug this in right there, file and save. And so now what we need to do is on false, we need to actually do a proper check right here of whether we can actually input this. So that check is going to need this information, and it's going to check get location at distance along spline. And what we're going to do is we're going to compare the directions to see whether they're too off, meaning if it's on an angle, we don't want it. We only want it when it's going straight, or at least to a certain degree. So we want this, and the first one here is going to be the distance itself. The second one is going to be the distance minus 100, as 100 is the edge of the actual box itself. So we don't need 200 here. And then we're going to do a copy of this and a copy of this, but the second one is going to be replaced by plus instead, 100. Like this, there we go. And what we want to do with this information is we're going to say get unit vector of these two. We're going to do the same thing, I believe, between these two. And we also want to do the same thing between these two. And we're going to be comparing this to this and that to that. So what this is this will check the unit between the middle and the end. This will check between the end and the beginning. And this will check between the middle and the end, middle and the beginning. So if ever there's a problem between these directions, meaning they're too off, then there's a problem. That means that we're turning in a corner and we don't want that for the splitter. So we check on absolute because we want to make sure that these are absolute, otherwise we'll end up with an issue, or at least it won't work all the time when we are facing the wrong direction. So what we're going to do is we will check if these are double equal, and that by default has a tolerance, which we're going to make a literal float for. And we're going to put 0.1 because that seemed to be working for me. If you think that is not the case, then you can always change it. It's not a problem. And so we check whether this and this are both equal, meaning that we're on a straight enough path to actually continue. So this does it for our is buildable. And just to test if this works, if we have a straight line and we try and place an item, there's no problem. But if we have a curved one like this and we try and place it, we can't actually put it down because it doesn't accept that kind of thing. Now, on the other hand, if we do this normally, there should be no problem. We should still be able to place it here because it considers it still straight enough. So with that, we finished our conditions for is buildable. We just need one tiny little thing, and that is for the scroll. And the reason we have this specifically is because we want to say that if this is invalid, if this is valid, sorry, we don't want to be able to rotate. And the reason for that is very simple. If you're on the conveyor, you don't actually want to be able to rotate because it should be automatically aligned, which it is by default. So compile and save. And now we can actually move on to the inputs and outputs. Now, I'm not sure if this is the best way to do it, but we'll do it in this way. That way we're done with this and we can move on to the splitting itself. So we want to get input from attachpoint. And that's where most of the changes, I believe, happen, because the default one we have doesn't work for this system, because normally we input from an attach point. It goes in, it gets stored. Once it's finished crafting, it goes to the output, and then it gets outputted. But in our case, we want the item to stop in front until it can be outputted, at which point it will be destroyed and moved. So we can't use our default one. So we're going to delete that. And what we want to do is we want to get attempted inputs, and we're going to add these immediately. And the reason we do that is that way, right from the get-go, we can say, hey, this is the item waiting to come in. So if at any point we can start inputting again, it'll get inputted. So then we want to check this time, instead of can input, we want to check if we can output an item, because that's what actually determines whether we can input an item in the first place. So if we can't, we return false, no problem. But if we can, we want to do it in two parts. Now, the first part is, well, first, before that, we need a value here. We need an integer, and this is called the, I believe, output switch, and it is an int, not 64, just an int, and it can have a default value 0, it doesn't matter, what we want to do is we're going to be setting it in two scenarios. So first we'll go through this one, but they're going to be the same logic. So we'll make this one first. So for loop here. And so the first one here is simply going to go through and use our output switch to see whether there's a possibility of going through that output. If there isn't, it'll find the next available one in our array of outputs. So to check that, we need to get our outputs. We need to get the length, and say -1. And this goes into here. And this then gets set to our new switch output, which can then be used right here with a reroute. And this is where most of the logic is going to be. So if this returns, then that means it is true, because normally by default, if we can output, it's going to be true at some point. So normally this shouldn't ever get called, but we'll say it happened and it succeeded anyway. So then we want to get our outputs again, and we're going to get our keys, and we're going to actually use, well, our output here switch to determine which key we get to use. So we say get, there we go. And so now we can use the actual function that we made in our parent earlier, which is can attachpoint output. And this will just check if the individual one can output, and it will move on from there. So if, for instance, we go through here directly without doing the for loop, then if we fail, it's going to go to the next then and start with a different value here. So next what we want to call is we want to say, well, output map modified, or modify output map. And the reason we do that is so that we can call it and say, well, hey, the value's changed, take this into account before we start outputting. So we then get input item, and this is the variable we're looking for, and we want to get the structure. And the structure is going into the value, because that's what we're going to be trying to output later. But here, unlike normally where we would just say start outputting, we can't do that because we're going to need to modify it later so that it takes into account, because this is what gets called, this function here, start outputting, is the one that gets called by an item once it reaches past a certain point in the array. On the conveyor belt. So once it reaches 100 units, it will say start outputting to see if it can output the next item. But we can't do that because, or at least we want to change how start outputting works. So that means we can't call it here because it doesn't function properly anymore after what we'll do. So we're going to remove that, and we're going to use our other alternative, which is output from attachpoint, because we know all this information. We don't need to worry about it. So we then need to break this so we can get the item data. And this will do the trick for what we need to do here. We just now need to say, well, hey, we just got rid of we just started outputting, so we get attempted inputs. We say find our attach point, and we can then say destroy actor, because now we no longer need the actor, it can actually be removed, and in doing so that should make the rest continue to move. So let's move that. So the last thing we need to do is we need our outputs again right here. We need our length, and we're going to be modifying our output switch as it needs to be incremented. So if this +1 is superior or is superior or equal to length, then that means that output needs to be equal to 0. That means we're past the limit, so we put output to 0. Otherwise, we just increment it like this. There we go. And on both of these, we just return the node that we succeeded. So compile and save. So this will do it for our new input point, or input from attach point, sorry. So the next one is we need to know what the conditions are to output, because currently the conditions are you can output, and that's not correct. We don't want to be able to output all the time. So to do that, we need to override it. Can output right here. We're going to get rid of that one. And what we want to do is we get our output, we get our keys from the output, and we're just going to use the function that we made earlier as well, and say, well, for each loop, like this, there we go. And we will say can attach, or can output from attach point, sorry, I keep forgetting it's the other way around. And if this is true, we want to say that there's a means to output so we can keep going. But this time, if we reach the end, that means we can't output. That means none of the outputs have a way, or none of the attach points have the means to output an item. So then we can start saying, well, hey, how are we going to modify these start outputs? So how are we going to modify these start outputting, sorry. So it's not that complicated. We just want to do this differently. Usually we would just start outputting for every item in the outputs, but we can't do that here. So what we want instead is we use the attempted inputs, because those are the items that are waiting. Those are the items that are attempting to come in through the different sides. So in our case here, there's only through the north because there's only one input and 3 outputs. But in a merger, there'd be 3. So we need to use this. So for each loop, and very simply what we do, we get our attempted input. So we find, sorry, from attempted input here, we find it and we put the array element like this. And we want to check if this is valid, because normally by default, this start outputting cannot be called unless an item has already passed through. And if an item has already passed through, then this already exists. It just might not have a valid value, but it does exist. So we then say restart movement. And so this will attempt to restart movement. And if it's already at the end, well, it will call that it's at the end and it will try and output itself next. And so with this, I believe that is everything as far as the functions go. Now the more complicated part. Because currently right now, nothing will work because nothing is set up as far as the conveyors go. So we need to make a modification to the conveyor, and that'll do the whole thing, then it will all be ready. So let me just go and open that up. There we go. So we have one function we need to do here, and that function is called split conveyor. So we're going to make that, well, it's split conveyor, and it takes in an input called, well, we'll call it the middle, but pretty much it's a splitter or a merger. So get this exactly, and we're looking for the buildings underscore ms. There we go, right here. Compile and save. As now we can just go quickly back to our ms. I don't know why we have building container open yet, or still, sorry. And on place build, if our conveyor is valid, then we can say split the conveyor. And the middle is self. And so that will do it for setting this up. So now we can go to our conveyor. And we need a 3-way sequence here. The first part is going to deal with the first split. The other one is going to be the second. Then one is going to deal with the second part of the split, so before and after. And the third one will simply be destroy build. And that's just going to get rid of the previous one once we're done. So what we start off by saying is spawn actor from class. And the transform is get actor transform. This, and we're looking for our conveyor, because that's what we're just remaking a new conveyor here. So this will be promoted to a new variable, a local one we will call new conveyor. There we go. And we're going to have another sequence. Now the first part of the sequence is going to be for doing the beginning, the first point, because of how this works. We're going to use the same logic we have before, so with our update location and all that, and our place build. So with our new conveyor, we're going to say update location, like this. And then we're going to call it again and say place build. There we go, like this, like that. There we go. Not like that, because we're going to need a bit of space below. So here, what we need to do is we need to make our own hit result. Now, based on pretty much the information that is already in our update location here, we just want to perform kind of the same logic here. So we need to mainly get the hit actors. That's the most important part. So to do that, here, we can't just simply say what our attach point is. We need to know whether there's a support, whether it's an attach point. So to do that, we want to get our other start AP. And this is from the conveyor we're currently on, the one that we're going to delete. We're going to check if it's valid. And if it is valid, we can actually do a select here. And so the wildcard is going to be the is valid. If it is, then we can put our other AP. Otherwise, we want to call these start support. That's what we're attaching it to. So this should be enough here. I don't believe we need anything else. We'll just collapse it. We might need to add the location, but I'm not 100% sure about that. So for now, we'll test it like this. The last thing we need to do here very quickly is we want to get from our new conveyor again, and we want to get the start support. And with our start support, we can then say to hide this actor. Because either way, when we're splitting down the middle, we're not going to start thinking about spawning extra supports, because that's not necessary. So set it hidden. And the next one we need to do is we need to do pretty much the same thing, but because we did our place build, we're now starting the second attach point, so the second part. And so we need to now this time, and this is from testing, so this is kind of the only way I found. There's probably other ways if we went about it differently, but we want to call update location twice here. As how it works kind of, and this is a mistake on my part, in update location, if we go into update spline shape, right here, how this works is it will go through our logic here and it will spawn a new actor. And the problem is it will spawn this, but it won't update its location later because this is a branch. So it needs to actually call both of these, which is why we need to call it twice in some scenarios. So in this case, we need to call it actually twice because usually it's on update, so it does it multiple times, so we don't have that issue. So what we need here is once again another make hit. And what we're looking for is from our middle this time, because we're trying to connect it to the middle. We need to say get south, and what we're looking for is the child actor. And so we plug this in because this alone can't actually go into the anything here, but the child actor can go to the hit actor. So we need to make sure that this is all nice and tidy. It doesn't have to be, but then we need to make sure that it's connected to the second one as well, because we need to do this, as I mentioned, twice. Now, once we've built this, we need to check here this start AP, and if our other start AP is real, so meaning we have one so that it's valid, then we need to actually call link connected builds manually, because for some reason it doesn't work otherwise. So just to make this tidier, we can connect these, they use the same logic, it doesn't matter. So let's just line these up again. And so now we have the first part. So if we test this, so we go and let's say add a conveyor here, and we say 4, so we have a problem. So obviously this isn't what we're looking for. I believe it's because of, yeah, as I mentioned here, we do need the location. So for that, what we want to get middle, and we want to say get actor location. And I think this should fix it. Make sure you put it into impact point and location. I think we only use impact point, but just to be safe, we'll do it this way. Compile, and we'll do the test again. And obviously this is only doing one half for now. We haven't done the second. So now if we place it again, still not working. So why is that? So the reason is because this is wrong. It should be north. So that's my bad. I should have gotten that right. It's just different from my one because I got them in the different order apparently. So if we now compile and save, that should fix our issue. So now it should no longer kind of mean looping back around. As you can see, the attach point is here as well. And the items will stop now here, and there is nothing in between. If we check, it does indeed stop right there. So next is to do the other half. And so for the other half, it's going to be very similar. We're going to give it a bit of extra space. So we're going to be copying a lot of this for the other half. So first we'll copy this. That's pretty much going to be identical every time. And I believe for the second half, what we do is we're actually going to copy this. Or at least we're going to copy this part here, like that. And then we're going to copy this from it, because we need to hide it always on the first one. There we go. And so we add a sequence, plug this in here. Now obviously this time we need to use the south. So we'll get south here, and it should all be all the way at the bottom. Plug this in. That's all not very aligned, so let's just try and place it up. Line these up. There we go. And this does it for the first part. And then we need to do the second one. And the second one is also going to be very similar to this as well. So we'll just copy this, place it down here. And this time we also need to actually do this twice. So we'll add a reroute here and say update location, plug this in, and there we go. Now this time, obviously, we don't want the start, we want the end. We don't want the other start, we want the other end as well. So other end, make sure you're using other end and not this end, otherwise it'll be a problem. So there we go. And middle can be the same because pretty much it's just indicating that we hit somewhere in the middle so that it knows which direction to place relative to the support if it hit the support. And to finish, we also need to do the same trick as we did before here. Like this, I believe, yep, at the bottom here. Like this, but this time we want to use this end instead. So this end, plug it in here, and we want to replace you also with other end, so like that. There we go. So this should do the trick for our splitting. So let's give it a try, see if this all works. So we make a nice spline, and as you can see, it's working. So we have our first line here, it stops, we can see the attach point. Here we have our new attach point, it moves all the way to here. Now I'm not sure if we can actually check the attach points are valid here. So we cannot, the values aren't visible, but I'm assuming they should be correct. And so we can actually test that by going and putting some coal in here and connecting it up. Let's see. I don't know what's going on here. It's because we're not actually placing them. So on begin play in our A building, so we need to look at the parent here. On the begin play, so let's go into here. So we're calling this and we're setting them to ignore, but at the same time, we're not actually telling them to not be reset after. So I think what we can do instead of this, we will get rid of that. We'll put it back to how it was before, but we'll do it in the pickup or the move build. So I think in placement right here, we have place build. We'll do in create build the same trick as we did in place build, but the other way around. So we'll just copy this, going to create, and we'll do the opposite. So here in this one, we make it ignore. There we go. And so what this will do is instead of doing it on begin play, meaning all of these items here can't, now they should be fixed. Or actually, now that I think about it, they are not. And the reason for that is because create build is called by default in those buildings as well, isn't it? Okay, so what we'll do to fix this, because this is how it should work, right? Because the reason is these items are already placed and that's why they have an issue. If we do it, for instance, with, let's say, our item here, this won't be an issue because it's actually being placed and told to update. So we'll just use this instead to do our test. So we need to make this very long, place it here. And so here the items didn't connect correctly. So if we get rid of this just to test, we can reconnect it, it moves again. And hopefully it goes through, no problems. Now we're still gonna have to test it anyway. So items go in, correct. And obviously if we do this, items come out on the other side. And we do the same here, just to split it. So now we'll do it once out of twice. It will go for each one and try. And it will stop once it's actually blocked. There we go. If I remove one here, it knows it can keep going. So it's working as intended, except for the fact that, well, it bugged out a bit. So let's try and figure out what happened there. So if we do this again, drag it out, because it could be the same problem that we've had before where it does know. Yeah, so I think what happened is because I placed it slightly under, so it duplicated the actual item itself. So let's just make a few more here, and then we will test whether we can actually merge them. Well, actually, no, we can't merge them yet because we don't have an item to merge them with. There we go. So let's actually extend this so that we can see if it's splitting all three. So as we can see, it's making a selection and actually deciding which one to go through. It's going left, well, right, left, right, middle, left. And so if it can't, if there's another space, it just simply chooses the two that are available. until they are eventually filled up. And yeah, so now it's going to only go right for a little bit until it gets filled up itself. Then it stops. So it's working as intended. We just need to make it do one last thing, and that is what we need to make it so that it does also the splitter or the merger, because currently it does the splitter. Now, one thing we want to change here, and this is very a minute detail. First, we want to create our child, and this one we're going to change from ms to splitter, and then we're going to duplicate it. It's the same as making another child, and we're going to say merger. And for splitter, we leave it as it is, doesn't matter. For merger, on the other hand, we're going to have to make, no, not ms, we want merger. Now for merger, we need to make a small change. And this is on event begin play, so we need to actually open full. Detach this, can move these, we don't need them. We need to get our east and our west, and we want to make an array, like this. And we're going to go through them. And why we need to do this is because we actually need to inform them to change here, because I don't know why this is like this in Unreal, but if we try and change the template here, it actually changes it in the parent. So if you want to change this to input, that'll change it in the parent, not the actual item itself here. So that doesn't work. So what we do instead is we get child actor, we cast to attachpoint like this. And then we get to say, well, direction, get set direction, and this time to input, because we want to input, we want to merge them. And then we need to make sure that we say update size, like this. Plug it in here. And we can also, just to be safe, because otherwise this will go to 0, 0, I believe, or does it know that 0, 0 is to ignore? Okay, no, so it doesn't know that. So what we need to do here then is we need to say get vector size, plug that into vector size, and get location offset, and plug it into here as well. And on return, on complete, we need to make sure that we do the rest of the begin play. And with this, we now have our merger as well as our actual splitter. Now, one thing to take into account is we no longer need this because we have our merge and we have our splitter here. So what we can do is in our class settings, we can go to advanced, and we want to make sure that this is an abstract class. So for those who don't know what that means, it just means that the class itself exists as a blueprint and not a blueprint like Unreal Blueprint. It's just a blueprint that's used to create the children of this class, but itself cannot be called. It cannot be instantiated, cannot be created. So in doing that, we remove the risk of actually calling this, and we can use it specifically in the cases of like our building. We can do the same thing because we don't actually want it to spawn. We just want it to be used as a reference. So the same here. And so what this does is in our Satisfactory here, normally MS shouldn't be usable anymore. If we try and normally do for now, it doesn't actually work, because that can't work because it is instantiated or cannot be instantiated. But if we now replace it by our splitter, it'll work exactly the same as it did before. So now we just need to add a fifth output, or a fifth input more like, for that scenario. So we just go and do that. Object 5, this is, and we use 5. And so now with this, we can go ahead and simply, in our player, call object 5, place it in here, and we'll say spawn build as well, on started, not triggered. That'd be bad. And we want to put our, I think it's merger this time, yeah, a merger. So compile, and that'll do it. Now, obviously, visually, there's no difference for us, so you'll have to know which one you're using, but just for testing's sake, it doesn't really matter too much. Let's just move this all the way down. 4 for our splitter. There we go. And now we will add a merger here. So just to make it easy to test, we're going to do it like this. Let's just make sure I don't run off the edge, that'd be bad. So 5 for our merger, and we can see via the arrows that this is what it's going to do. Now these are all going to stop, but if I connect this here and connect you to this, oh, it's not going to actually work because it's too sharp. There we go. They'll actually start connecting up. So same thing here, it's a bit too sharp. Plug it in like that. And just to make sure this is working correctly, we'll just extend this a lot further. And so as you can see, they're all kind of taking turns because, well, there's no other way to do it. Except the right one that isn't actually moving. Oh, it is. So it was just waiting its turn very patiently. Okay, so that does the trick. Now it actually starts waiting and then merging the items back together. So I believe that does it. So that's it for this video. Hope you enjoyed. In the next part, we're going to be going over the energy, and that'll be the last tutorial for this series at least. So I will see you in the next one. Goodbye.